Next, please welcome Jack McCauley, co-founder of Oculus VR, to deliver us a fascinating speech. Let's welcome Jack.
Thank you. My name is Jack McCauley, and I'm an engineer. I spent 40 years working in entertainment. I worked on feature films, Terminator 2, Edward Scissorhands, Dick Tracy, and I also worked on video games. The latter part of my career was spent working in video games. I have a very high level of education. I'm very fortunate that I went to a public university, and that's where I now work. I work at UC Berkeley. I teach sustainability and environmental engineering, which is an interest of mine. So everyone's heard of ChatGPT, correct? This is what it says about me. It says, Jack McCauley is a well-known American inventor and engineer who has worked on a number of high-profile projects in the tech industry. He is perhaps best known for his work on the original Guitar Hero controller, which he designed while working at Red Octane. I built hardware. That's primarily what I did, but I also did other things too. And McCauley also worked on projects for companies like Electronic Arts, Microsoft, and Oculus VR. And he is widely regarded as a talented and innovative engineer, and his contributions to the tech industry have been significant. So this is not particularly true. ChatGPT harvests data about individuals and people from common sources, Google and so forth, Wikipedia. So I'm very fortunate, again, to get a good education and support of my colleagues in my career. So these are some of the things that I've invented. I invented the scrolling wheel for the computer mouse. Of course, Guitar Hero, which was a very popular $2 billion video game franchise. And Oculus VR is a co-founder of Oculus, one of the people that founded the company. And I had no idea that the company would sell to Facebook, but it did. But my job there was to build the headsets, which is what I did. I ran the team. I didn't actually physically do it myself, but I ran the organizational part of it, which involved much travel to China, which I've spent much time here, Hong Kong and southern China. So these are my career credits. Chief engineer and co-founder of Oculus, chief engineer at Guitar Hero. I worked on Terminator 2, Dick Tracy, Edward Scissorhands, a technical contributor, and the system that we built for those 3 films won an Oscar. I didn't win the Oscar, but the company that hired me did. And I teach at UC Berkeley, and I also am a member of RAND Corporation, which is a research think tank in Southern California. I'm a board member of the Math Institute in Berkeley, and also a trustee at the UC Berkeley and Asia Society trustee. So I want to show you something. This is from Terminator 2, and this is the point of my talk here. I'm going to talk about what drives AI, and I maintain that AI is driven by video games, and in a funny kind of way, not the way you would expect. So let me play this. This was Terminator 2 came out in 1993. It was rendered. It's the first fully digital rendering of a feature film, the very first feature film that had rendering in it, like a video game. Of course, back then, the video game rendering engines were done on a standard computer, and now they're not. They're done on what's known as a GPU, graphics processing unit. And the graphics processing unit is the engine which creates these frames. So let me play this. I'll explain what goes on here. That's rendered. That's rendered. That's rendered.
What the fuck is it? What the fuck is going on?
Pardon the language. So, that entire sequence, the things I pointed out were renders. It took 6 weeks to render them. In other words, frame by frame, it took 6 weeks. You can do that now in real time in a video game, it does it just as you're playing it. And the revolutionary work that James Cameron did here involved many new things. He built a own render studio. It was done on what's known as a Sun workstation, a quad-core Sun workstation, 4-processor Sun workstation running Unix, and they had 28 of them running in parallel to do the renders. You can do that now with a chip from NVIDIA, the whole thing in real time. That's how far advanced we are now. I'm going to contrast a video game. I worked in video games, right? Doom from 1993. It's a rendered game, and a game that's new, that came out recently. And it's done on a commercial game engine. You buy a game engine license to write your video game around. So I'll play this. Watch this. Game's called Unrecord. I love this kind of stuff. So. But look at that. Just a 30-year difference. These are both in real-time renders. Slightly different architecture.
Shots fired! Shots fired!
Quite a contrast, right? It's essentially a supercomputer that you buy on a chip. On a computer, it's called the number of cycles per second it can do, math operations. And right now we're about 1.1 teraflops, trillion floating point operations per second, trillion. With later GPUs, which I'll show you in a minute, they're much faster than that. So a GPU is a graphics processing unit, as I mentioned, and its job is to take primitives, which the game delivers to the GPU, which are sort of what the scene is supposed to look like, and it shades them and renders them in real time. And most video games now use a GPU. Most of them do. You don't have to have a good video game. A video game is just not all about the visual stuff. I worked at Oculus, right? It's a visual sort of thing, but it's not. It's about gameplay, how well the game plays. That's what detracts people. You can have like Tetris, you know, which people play. It's a very popular game. It's the #1 video game ever. You can have Tetris, which is a very simple block game and keeps people entertained. And a rich video game that's very rich in visuals doesn't actually mean it'll sell well. Without video games and entertainment pushing the boundaries of computing power, my argument here is that the GPUs, the commercialization of entertainment, of video games, drove the GPU technology. A GPU does the same math operations that AI does. It doesn't do them exactly the same way, but it's pretty much what's used in AI. And I think, you know, I watched NVIDIA grow as a company. They're in San Jose, California, Santa Clara, California. And they were in a little building, probably this size of this perimeter here, not 12 years ago. And now they have a huge campus. And all of it is being driven by demand for their GPUs. Jensen Huang is the founder of NVIDIA. He actually helped Oculus with their headsets. Jensen did. A great guy. So check this out. There's this thing called Intel ASCII Red. Came out in 2000, right? You can see here, this is in 100 billion floating point operations per second. That in 2000, year 2000, you could do 2.5 billion floating point operations per second, all right? So where are we now? Let's take a look here. PlayStation 3, it's about, I would say about maybe about 200, something like that. And so PlayStation 3 is right in the middle there, and look at the PlayStation 4, and that's using a GPU. It's breathing down the neck of a supercomputer in performance and horsepower. So iPhone 14 is now faster in floating point operations than the PS4. Your phone, you know, iPhone 14, I've got one. So this is the advance that's happening, and the reason that AI exists today is because of this. So this is a NVIDIA Titan V GPU. You take this thing and you buy it, and you put it in a desktop computer. It's called a gaming rig, that's what we call it, and you put it in there, and you can buy it on Amazon. That has the equivalent of a supercomputer from 10 years ago, processing power. That's the demand that entertainment is placing on computers. So at 110 trillion floating point operations per second, it's 110 trillion. So that's very, very fast. So this is the core of what a GPU does, and it does these things called linear algebra matrix operations, multiplying huge numbers of multiple dimension arrays together very, very quickly. It does it in floating point, which means it's a real number operation. That's what it does. Incidentally, this is very similar to what AI does. So AI is based on neural networks. It's an artificial brain, kind of. And a neural net has interior connections and synapses, just like your mind. It's modeling your neurons. So incidentally, it will never be able to do what your brain does. It can't. There's different types of neurons in your brain, and this is just sort of a basic neuron. So neural nets must be trained by input. So as I formerly pointed out, with what ChatGPT said about me, it's often wrong. It gets things wrong. And the math operations of AI are similar to GPU operations that are done in video games. Without video games, there would be no push, really, for fast coprocessors and supercomputers. So the math operations in AI are similar to GPU math operations. And so this is a neural network. So I'm a technical guy. I'm not going to talk too much technical stuff here, but there's an input layer and hidden layers in between, and an output layer, which is a crisp output. In other words, it gives you the right answer. And the hidden layers are all connected together with little software neurons, and those are either strengthened or eliminated to train the neural network. Incidentally, if you had a copy of a neural network that's been trained, you can simply load that neural network into the GPU and perform as if it learned it all along. So you teach it, and then you store the result, and then you load it back into the GPU, and it gives you the crisp output. So it has to be trained first. So what drives AI is something called a TPU. It's a tensor processing unit. And it's essentially a GPU that's been tuned for AI, but it's essentially a GPU. So Azure One, which is the engine behind ChatGPT, is Microsoft's cloud-based service for AI. You pay a subscription fee, and you can use their AI engine. You don't have to have a rack of GPUs, a big server room full of GPUs. They have that for you. This is a great business. And I think Elon Musk is interested in this kind of business. He's buying GPUs. He started his own. Tesla purchased an AI company. Tesla's located the factory's located about 20 minutes from where I live. So incidentally, I drive by it every day. So just about, okay. So it's essential to have a cloud-connected AI service, because you can't simply just buy an AI server rack. You have to use it as a service. So my argument is, again, that it would not have happened without video games. Entertainment drove the GPU technology. The demand for graphics processing drove it, really. And that's all I have. I'm going to take some questions, if anyone has some questions for me. Nothing? No. Thank you. I finished early.
Thank you. Thank you, Jack. Thank you, Jack. Wonderful speech.